Hello students, in today's session we will do a very conceptual question on non-uniform circular motion. Yes, this is a question which won't involve any calculation as such, but it will test your understanding. So, let us do this question. The question says that there is a pendulum bob and it has an amplitude of 60 degree. There is a pendulum which can swing up to 60 degree on either side of this vertical line. Consider the pendulum bob when it is at an angle of 30 degree on the way up. Now, this particular pendulum, it can go up to this point, but right now when it is here somewhere midway, this angle is 30 degree. Question says consider this pendulum bob at this moment when it is making when the string is making an angle of 30 degree with the vertical, right, and the pendulum bob is moving up. The question says pendulum bob is going up. What is the direction of acceleration of the acceleration vector? What is the direction of acceleration vector of this bob? ये जो पार्टिकल है उसके एक्सेलरेशन वेक्टर का डायरेक्शन क्या है? ये डायरेक्शन है, ऐसा कुछ होगा या ऐसा कुछ होगा या ऐसा कुछ होगा. इनमें से कौन सा ऑप्शन आपको सबसे सही लग रहा है ये आपको बताना है सबसे पहले. और फिर क्वेश्चन कहता है नाउ कंसिडर द पेंडुलम एट एन एंगल ऑफ 30 डिग्री ऑन द वे डाउन. नाउ अगेन कंसिडर द सेम पेंडुलम बट दिस टाइम इट इज कमिंग डाउन, इट इज ऑसिलेटिंग. तो यहां पे ये ऊपर भी जा रहा हो सकता है, थोड़ी देर बाद यहीं पे वो नीचे भी जा रहा हो सकता है. सो व्हेन द पेंडुलम इज ऑन इट्स वे डाउन, इन दैट केस व्हाट इज द करेक्ट डायरेक्शन ऑफ इट्स एक्सेलरेशन? जिस समय पेंडुलम बॉब यहाँ पे है और नीचे जा रहा है, इस वक्त इसके एक्सेलरेशन वेक्टर का सही डायरेक्शन किस डायग्राम में दिखाया गया है? ए, बी, सी या डी? बच्चों सभी लोग अपने वीडियो को पॉज कर दीजिए. देखिए मैं स्क्रीन से हट जाता हूं, आप यहाँ पे पॉज कर दीजिए. क्वेश्चन आपको साफ साफ दिख रहा है, आप खुद से सॉल्व करने की कोशिश कीजिए. नहीं कर पाए या चेक करना है कि सही किया कि गलत, तब आप मेरे सोल्यूशन को देखिए. ये क्वेश्चन जैसा मैंने पहले ही डिक्लेयर कर दिया, इट इज बेस्ड ऑन नॉन यूनिफॉर्म सर्कुलर मोशन. तो एक क्विक रिकैप आपके लिए, व्हाट इज नॉन यूनिफॉर्म सर्कुलर मोशन. इफ अ पार्टिकल इज मूविंग इन अ सर्कल, at a constant speed, its motion is said to be uniform circular motion. In that case, the acceleration of the particle is always directed towards the center of the circle. The acceleration is always radial along the radius and its magnitude is v square by r, where r is the radius of the circle. I repeat, when the particle is moving in a circle at a constant speed, its motion is said to be uniform circular motion and its acceleration is always directed towards the center of the circle having magnitude v square by r. But imagine a situation when a particle is moving in a circle but its speed is also changing. When particle is moving in this circle and its speed is, let us say, increasing, in that case its acceleration is not exactly in this direction. Now to make things simple, we think in this way. Basically we think that this particle is moving in circle and let us say its speed is increasing. So now we think that the acceleration of the particle has got two components. There is one component which is along the radius, this is equal to v square by r, and this acceleration is responsible for changing direction of the velocity. Because of this acceleration, the velocity vector changes direction. And there is another component of acceleration that is along the tangent. It is known as tangential acceleration. Its magnitude is rate of change of speed dv by dt. So when there is no tangential acceleration, means speed is not changing, which means particle is moving with constant speed, acceleration is v square by r. But when the speed is changing, it can happen only when there is an acceleration along the tangent. If the speed is increasing, then the acceleration must be in the direction of velocity, and when the acceleration is opposite to the direction of velocity, it means its speed will be decreasing. जैसे आप इमेजिन कर लो कि आप एक रेसिंग ट्रैक पे बाइक चला रहे हो और आपकी स्पीड बढ़ती जा रही है. In that case, there is one component of acceleration towards the center, another component is along the tangent, and your resultant acceleration is vector sum of these two components actually. So your resultant acceleration is in this direction. So, when a particle is moving in a circle and its acceleration is not exactly along the radius, it means the motion is non-uniform circular motion. If the acceleration is directed this way, it means we can find the radial component as well as the tangential component if it is required. If radial and tangential components are known, you can just add them vectorially to get the resultant acceleration. So, with this concept, let us go back to our question. The question says this pendulum bob is going up. Okay, let it go up. It is moving in circle. If at this point in time it has some speed v, then students, it must be having one acceleration towards the center of the circle. It is going in circle means there is a radial acceleration which is equal to v square by r. Now, what do you think about this speed? What do you think about this speed? When it is going up, its speed is decreasing, right? So, there is a tangential acceleration in this direction as well, opposite to the velocity. If you ask me why there is a tangential acceleration, the answer is pretty straightforward, because I'll just use this diagram. On this pendulum bob, there are only two forces, mg and tension in the string, right? We can resolve this force mg into two components, one along the radius in this direction and one along the tangent. This force can be broken into two pieces, one along the radius and another along the tangent. Now, these are two perpendicular directions, radius and tangent. In the tangential direction, there is only one force acting on this pendulum bob. mg का जो ये component है, that is the only force acting on this pendulum bob in this particular position in tangential direction. So, this is the force which is causing an acceleration in this direction, and this is the tangential acceleration. When there is no force in tangential direction, there will be no tangential acceleration, there will be no change in speed. So, from practical experience, we all know that when the pendulum bob rises, its speed decreases. That means there is a tangential acceleration. Which force is responsible for that tangential acceleration? Answer is tangential component of the weight. mg का जो tangential component है, that is responsible for producing the tangential acceleration in this pendulum bob. Now, when the pendulum is going up, there is a radial acceleration, there is a tangential acceleration. If you vector sum these two, you will get a vector in this direction. Depending on the magnitude of this and this, it can be this way, this way, this way, or this way. So, the correct direction has been shown in option D. It is not towards the center, it is not along the tangent, it is somewhere midway between the tangent and the radial direction. So, answer to the first question is D. Now, what happens when the pendulum bob is moving down? The answer remains same. Why will it change? Ultimately, acceleration is caused by force. So, whether the pendulum bob is going up or whether it is coming down, forces have not changed. Forces are the same two forces, tension and mg. When pendulum bob is going up, this acceleration or this force is decreasing its speed, and when it is coming down, the velocity and this tangential force, they are in same direction, therefore its speed increases. So, it is a common knowledge that when pendulum comes down, its speed will increase. So, its speed is increasing, tangential acceleration this time is in the direction of the velocity, but the direction of tangential acceleration, it will be decided by the tangential force. Force has not changed whether the pendulum is going up or coming down. We need not look at the direction of velocity at all. The direction of force remains this only, therefore tangential acceleration will remain in this direction only. Doesn't matter whether the pendulum is climbing up or coming down. I hope you have understood this concept. Students, see you in the next video, but before that, don't forget to subscribe to this channel. Here on this channel, I, Shashi Bhushan Tiwari, I am repeatedly giving you tips, tricks and concepts for your JEE advanced exam. Goodbye.